All right, guys. Any questions from homework or anything? Or?
Oh, I didn't get a new one made yet. Sorry.
I know, I suck. You can always come by my office, and you can always sit down and look at them directly in my spreadsheet. Yes?
Just 110 on 10.
You guys got a question? 10, 1, 110?
I like that.
10, 1, 110.
10, 1, 110? Oh, all right. Okay, this is beautiful. So real quick, somebody remind me. All right, I'm going to work my way up to your question, okay? As long as you answer it. All right. What's the domain of this guy? Everything except. Yeah, because domain, again, domain means all the x values you're allowed to use. They have valid outputs. That's what allowed to use means. And of course, x can't be -4 because that makes what happen? 0. On the bottom. And that's no good. So what about this one? Don't worry about 2. Okay. Screw the top. Doesn't matter. -2 squared is, and then you get an 8 on the bottom. What's the smallest that x squared can be? 0. Because the minute you get away from 0, 1 squared is 1, -1 squared is 1. So the smallest it can be is 0. What's the smallest the bottom can be? If that smallest is this is 0, what's the smallest the bottom can be? 4. If this piece is the smallest this piece can be is 0, then the smallest the bottom can be is when this is 0 is 4. And the only x's you throw out are the ones that make the bottom 0. The sucker never gets close to 0. It's the smallest it gets is 4. So what's the domain? All real numbers. Nothing makes this bottom 0. Yes. Yes, no, maybe? No? Not at all? It sucked? Shit. There is a value of x that makes that 0. -4. What makes this 0 on the bottom? What makes this 0? 0. The minute I add something on top of that, there's no way to make that 0. In fact, set it up. X squared plus 1 would have to equal 0. If you subtract x squared, it would have to be -1. In order to make that bottom 0, you have to square something and get -1, so that when you add it to 1, you get 0. You guys, you get that? Okay, so this one also would be all real numbers for the domain because no x's make it 0 on the bottom. All right, now, we just moved up to this kind of thing here. How would I find this guy's domain? Can you say it in English? What has to happen inside of a square root? What are the only kind of numbers it can handle? Positive or 0. So they can come out real. So the inside must be at least 0. All right, let me stop right there. Does that make sense to say that? I mean, you can't take a square root of a negative number and have it come out real. I know I keep teasing, the shit's not real. We're going to learn about it. We don't know it yet. So right now, so the inside, 2x plus 3, has to be at least 0. And then I can solve that. So if I can say what has to happen in English, I can write down what that is in math and then solve it. It's almost too nice to believe or trust. Yes?
Is it always going to be greater than or equal to, or just greater than that? Or does it depend?
It depends on the function. We don't know that many functions yet. We really don't. There's a function that actually looks like this. Has anyone ever seen this function before? That's a funky ass function. It's one of the last things we'll talk about in this class. Every time we learn a new function, there are two things we're going to do with it. What is its opposite? Kind of makes sense, right? Addition has subtraction, right? Dark has light. Division has multiplication. Square roots have squares. Cube roots have cubes. Everybody's got some kind of an idea of an opposite. And then the second thing we want to do is, what am I allowed to use in it? Right? Actually, it doesn't matter which one you do first, but does that make sense? So a little bit. We have ideas of square roots, then we have ideas of squares. They're kind of like opposites, right?
Yeah.
We also have this idea of what am I allowed to use? What x values am I allowed to use?
Okay, one more question.
Yes.
So if it was t plus 8, it would be greater than 0?
If it was no, okay, all right.
Because that's what the t is for.
So what was the problem you guys were looking at?
4 square root t plus 8.
Oh, like the fourth root, maybe? Like that? Okay, fourth root,
T plus 8.
t plus 8. Okay, I really want you to understand. If it's an even root, it's got to be greater than or equal to 0. You can do any root of 0. What's the fifth root of 0? What's that mean? What does it take 5 of to multiply to be 0? 0. So you could do any root of 0 because the answer is always going to be 0. Same thing with 1. What's the fifth root of 1? What does that take 5 of to multiply to be 1? 1. What's a billion and 7 ones multiplied to be? Freaking 1. So what's the billion and 7th root of 1? 1. Okay, are you guys with me? What's going on? You guys all right? So your question is this. If I have an even, can I write like this? Is this cool? If I have an even root of something, what must be true about this? It has to be at least 0 to stay real. We haven't talked about, so therefore we are not allowing unreal things to come into play. Not Unreal Engines. All right. My point was, other functions will have different English statements I can say. They'll have different kind of domains to get. But roots, even roots, always have this. I like it. What about odd roots? How do I find the domain of... I kind of got a little bit away from your question. I'm finally going to come back to Dawn. What's the domain of this? Bless you. Who remembers what's the domain of this guy? Will somebody help me out? What's the cube root of 8?
2.
2. Why? Because it takes 3 2's to multiply to be 8. Right? These are all based on multiplication. So that's 2 because 2 times 2 times 2 is 8. What's the cube root of negative 8? Come on. Negative 2. Let's check it. What's negative 2 times negative 2? 4. What's 4 times negative 2? Negative 8. I really know. Watch. Why does an odd root work for negatives, but an even root doesn't? Give me a negative number, somebody. Negative 3. Negative 3 to the first power is negative. Negative 3 squared is what? What's negative 3 to the third power? Negative, positive, negative, positive, negative, positive. So if it's an odd root, I can have a negative beginning. If I have a negative 27, what's the cube root of negative 27? Negative 3. Well, what's the square root of negative 9? I don't get negative 9. Shit, there is no square root of negative 9 that's real. Because 2 negatives would make a positive. So when I ask you this question, where does negative 9 come from? The multiplication of what number by itself? There is no real number that does that. Because 3 times 3 is 9. Negative 3 times negative 3 is 9. What times itself is negative 9? Nothing. No. I love this idea.
Every other one is negative result, isn't it? And they're all related to what kind of power that comes out negative? Odd. So the odd root can handle negatives because odd powers can come out negative. Right? Yes? No?
Yeah.
Odd powers can come out negative. Even powers cannot when I'm using real numbers. I have to throw that caveat in because we will eventually talk about things that are beyond real. I like that better than not real. Beyond real. More real than real. But we're not there yet. So basically right now I cannot do the even root of a negative number. I cannot. Is that better? Yes? Okay. Because I understand why it's like, well, what the hell? You can suddenly do a negative before you said no. Well, it's because it's what kind of root? Even roots, more uptight. They can't handle shit. Why? Because they always come out, I don't care where I start, it comes out positive. Odd roots, they're cool. You can work your way back. So if I said I squared a number and I got 16, do you know exactly what number I squared to get 16? What did I square to get 16? You're wrong. Ha ha. Right? You can't tell me exactly because it could have been 4 or negative 4. You don't know exactly which one it was. But if I said I cubed a number and I got negative 8, where did they come from? What's the... Negative 2. There you go. It's got to be negative 2. So that's why squares and even roots have issues. But odd roots are laid back. They know exactly where the shit they came from. Maybe. No. Some of you guys are like, I'm tired of this. I'm sorry. As long as it makes sense. If it don't make sense, ask your question. Now, your actual question was something like this, right, Caitlin? I don't even remember now.
5 minus 5 is 5 minus, and then the square root of 3x squared plus 1.
I might as well just look at this one. Which part of this could have an issue? Which part of this doesn't matter or shit? I wish you guys could see this. Like, what's the domain of this guy again? What's the domain of that guy? X can't be negative 4 because it makes the bottom 0. So X cannot be negative 4. What is the domain now? Still frickin' X can't be negative 4. Did I change what the bottom was? No. So what part of this would have an issue somewhere? The 5 minus? Does he care about shit? No. The only part that could have an issue is this guy, right? That's number one, is to realize they can pile all kinds of shit on top. But all I care about is either what's on the bottom or what's inside of the root. Those are the parts that have restrictions, possibly. Now, does anybody notice something about the inside and what I was doing earlier? Who remembers what was the domain of this guy? It's been too long since I did this. I was building up to this.
It's just 4, right?
Well, the bottom can never be 0. It's all real numbers. The bottom can't be 0. I can't square something real and add it to 4 and get 0. Do you guys see that?
Yes.
You can't, because what would x squared have to be so that when I add it to 4 I get 0? It'd have to be negative 4. What do you square to get negative 4? I don't frickin' know. It's not real. I do know. But officially we don't know where we are in this class. You with me? A little bit? Do you guys see that? So this guy, what issue would a root have if it gets below 0? Can the inside even get to 0? Again, 3x squared, the lowest it can be is 0, plus 1. So the lowest the inside can be is 1. If the inside can never get to 0 even, so therefore it's never negative, what's the domain? All real numbers. There's no x value that's going to make this become less than 0. Less than 0?
Is that because it's an x squared?
Yes. Yes. I mean, right?
So could you put it, could you put a cubed in there? Inside of the square?
Now that would get a lot more interesting, right? I mean, well, we could still do it. So this would be all real numbers. And yeah, that's basically what I've been saying. I can't square something and add it to 1 and have it come out 0. I can't. Not yet. And the numbers we use are weird-ass numbers. So yeah, basically, no. Not with normal numbers. It's about to go somewhere else. Shit, I forgot. Oh well. Oh yeah, the cube thing. So if I had this, all right, let's see. Yeah, this will work. What's got to be true? Can you write it? Can you say it in English for me? What's got to be true for this to work?
X cannot equal -2.
Oh, I see. It can equal -2 all day long, dude. Because then what do you get on the inside? 0. So somehow it's got something to do with -2 though, because that's where it hits that wall. See what I mean? When it zeroes a wall in it, it's good up until 0, but the minute you try to go past that freaking wall, it goes. It's like holy shit. So what do? You fall back to the idea. What's got to be true about the inside?
It can't be less than -2.
No, don't overthink it. What's got to be true about the inside? The inside has to be greater than or equal to 0. Always start at what I used to. I had an Australian, what was it, nuclear physics professor. And he would always say, yeah, dude, you were doing some weird shit, man. He poured some, you've seen the liquid nitrogen stuff where you put something in there and you take it out and smash?
Yeah.
He poured some in his hand once. He was like, look at that, yeah, it's getting cold. We're like, pour that shit back in. But it rides on a thin thing of gas. It turns the gas next to your hand so it doesn't ever touch your hand. And he's like, it's getting cold. I'm like, put that back in, please. I don't want that. All right. So go back. What he would always say is go back to fundamentals. He'd say it with an Australian accent, but always write whatever the hell the inside is, it has to be at least 0. And then work with it. Here I can subtract 8. And then I can take a cube root. Ooh. There you go.
It has to be
Greater than or equal to -2. If the negative piece was too big of a negative, the overall thing would come out negative. You see that? So if I try to put -3 in there, -3 cubed is -27, plus 18 is -19. I can't do that. So that's why it's greater than or equal to -2.
So how come you can change it to a cube root when the original problem is...
No. This is a different problem. Somebody asked me, what if there had been a cube?
No, I know. So on the first
Oh,
one
no.
before, but
All
then
right, I'm
you
with you.
changed it to a 3. So why...
No.
why can't
Nothing
you
was
do that?
changed. Nothing. What's the inside? What's inside?
X cubed plus 8.
So from this, what's the domain? The inside has to be at least 0. Is there anything about the fourth root still here? No. But where's the fourth root's influence? Since it's an even root, it has to be at least 0. That's where the statement came from. The fourth, I didn't do something to get rid of the fourth root. What's the requirement? The inside must be at least 0. So I only have to work with that. So how would this have changed if this was the 14th root? Not at all. Since it's even, it has to be at least 0. What about a 1014th root? Same work. Because it's even. Yes?
If it was odd, would that sign?
If it was odd, what would the answer have been? 5th root of x cubed plus 8. What's the domain? Odd roots can handle what kind of numbers? Negatives, positives, and 0. Does that leave anybody out? No. So what's the domain? All real numbers.
For every
Done.
odd number, it's going to
For every odd root.
It's all going to be all numbers.
Yes, and I showed you an example where the answer wasn't all reals, and it's so this one would be all reals. The only way to have an odd root where the domain is not all reals is when I put a problem on the inside. Doesn't the inside have a problem now? The inside says x can't be -1. But the 5th root don't give a shit. So as long as x is not -1, the 5th root can handle everything else. Because like you just told me, it can handle negatives, 0, and positives. But what happens at -1? This becomes undefined. So the domain was not all reals, not because of the poor little root dude. He had no problem. It's because the inside dude had a problem. I really want you guys to see that. Anywhere I see a problem like a fractional kind of thing, the bottom can't be 0. So I don't care what else is happening, the bottom can't be 0. Okay, maybe. We really love that shit, but what I desperately want you guys to realize, right now, what we have, the two functions that we have that have an issue are fraction-looking dudes. So if I had 1 over something, in fact, let me do it like this. If I had something over something, what must be true, the bottom can't be 0. And then I solve for x. If I have this, what must be true? But even. That's got to be what? The inside has to be greater than or equal to. So there's an idea. I can only take even roots of 0 or positive numbers. Why? Because even powers can't end up negative. Since the square root's kind of like undoing an even power, and they can't come out negative, it can't undo a negative number. It can't figure out how to get back. I really want that to make sense. That's why odd roots work. Because odd root can come out negative. I can figure my way back.
So if it's a fraction, it's undefined.
If it's a fraction, when does a problem happen? If the bottom is 0. So I don't let the bottom be 0. I would solve this and see what x is I can have to throw out. That would make the bottom 0. Is that cool? That's what we were doing before. So if I had 3x over x minus 7, the bottom can't be 0, so the x can't be 7. If I saw this, the 16th root of 5 plus 3x, I would say the inside has to be at least 0. And then I see which x values make that true. And then I throw out the other ones because they don't make it work. Okay, maybe. I love this. Yes?
Okay, so back to that problem. On the third step, and it says third square root of x.
Cube root.
Yeah. Where did you get that from? Like, why
So
are you
it's like,
keeping the root?
if I'm trying to solve, got a headphone outside. If I'm trying to solve for x,
Yes.
what do you always do when you're trying to solve for x? Like, how would you solve?
Cancel?
Yeah, how would you solve this? That's a 3, by the way.
I would multiply.
Yeah, you do the opposite of divide.
Yes.
I love it. And so forth, right? Anything I
Yes.
throw at you. So what's the opposite of cubing something?
Square.
Cube rooting it.
Yes, sorry.
So if I cube root both sides, I get x by itself. Because what's the cube root of x cubed? X.
But okay.
Is that cool? What does it take
Yes,
3 of to multiply by x cubed?
Okay, now it makes
X.
sense.
That's what x cubed means. It means there are 3 x's multiplied. And then a cube root of negative 8 is negative 2. Cool.
I get it now.
I like that. And again, what got us going here was it was an even root. That's why I had to do something. The minute I make that odd, I didn't have to do shit then. I think we saw that over here somewhere. Yeah. The minute that's odd, it doesn't matter. As long as the inside's good, it's good. All right. Yes?
Can I do this with a calculator?
Do what part?
To get the answer, the final answer.
No. Is the short answer. Yeah, you could, but no. I haven't shown you how to do it, and if you figure it out from somebody else, I wouldn't give a shit. I'd want to see the work. Like, so yeah, there's a lot of stuff on the calculator. It will do certain things for you. But you can't like plug this in your calculator and have it spit this out. That's impossible. Okay. Oh, this poor little dude. So what I want to focus on, any other questions from homework? I think I fried everybody's brain with that discussion. All right. So, what I want to focus on today was a beautiful review of the last thing in 10.1. I want to come back to something we started on before. This idea here. I want to kind of prove it to you a little bit. I mean, on one level, this should make sense, because what's the square root do to something that cuts it in half? Right? Multiplicatively. And what are exponents based on?
Multiplication.
Multiplication. So if I put a 1/2 in the spot that deals with multiplication, it should mean half of this multiplicatively. So let's prove this thing, right? What is the square root of 49? 7. So any other way I have to do it better freaking come out to 7. Or else we can just throw that shit in the right place, right? So if I have another way to do this, it better come out to 7. So I'm claiming that this is true right here. The thing is, it's not written in a format I can use this form. 49 is 7 to the what power? What do you do with powers like this? Who remembers? When you have something to a power and you raise it to a power, what do you do with the powers?
Multiply?
Multiply. I love it. Sort of like, remember, what's x squared cubed? Yeah, I just said squared. X to the 6th power. Multiply those powers. So sure enough, what's 2 times a half? 2 times a half is 1. You get 7, which is the right answer. I like it. Now the funny thing, I don't think I've said this yet. Let's do another one. And then I'll tell you the weird thing that you don't hear a lot of math teachers say. What about the cube root of, what you got, Jeff? I don't know, dude. 64. Let's do this a different way. Watch, I'm going to do this on purpose, kind of like a slightly different way. 64 is 8 times 8, right? And each 8 is how many 2's? Yeah, so I get 2, 2, 2, 2, 2, 2. So I get 64 can be written as 2 to the 6th power. Is that cool? Take 6 2's to multiply to be 64. Now, if I'm saying the square root of x is x to the 1/2 power, what power would a cube root be? Cube roots do what to something? Cut it in thirds. Cube roots. Right? Just like we did when we had difference in sum of cubes, so they cut it into 3 parts. And we actually did write down the 3 parts so you can see them. So this should be the same thing as 2 to the 6th to the 1/3. A cube root cuts the thing in thirds. And again, what do you do with those? Yeah. 6 times a third is 3 goes into 6. So 2 squared is 4. And what is the cube root of 64? What's it take 3 of to multiply to 64? 4. So roots, another way to write radicals. That's what these are. These are radicals. Another way to write them is to a 1 over x power. 1 over whatever. Some of you guys look angry, I'm sorry. I really am. I tell you this, you're more used to this form, right? You're much more used to this form. To be honest, we should never have created this form. This is a much more useful form, and I'll show you before the end of the class why that's true. Right now, these are both the same stupid thing. Cut 49 in half, cut 49 in half. They both do the same thing. Right? So the minute we talk about fractional powers, we have to see how that interacts with everything else we've ever done with powers. Sounds like a lot, bless you, but it really isn't. So for example, what is x squared times x to the 5th? I know there's no fractions, just remember. X to the 7th. So what is x to the 1/2 times x to the 2/5? No.
10
math processes don't give a shit what's in there. What do I do with the powers? Add them. If I want to add these powers, what do I have to get? Common denominator. So I want x to the 1/2. That's the rule, right? That's the rule. When you have like bases multiplying, you add the powers. Does that say anything about what the powers are? No. Whatever the shit they are, you add them. As humans, we have to, oh man, I need LCD. So what's the LCD? So you get 5 plus 4. Get that. Like it. So half of an x multiplied by 2/5 of an x makes almost a whole x. How far away from a whole x is this? 1/10. I like it. I like it. So what is w to the 7/3 divided by w to the, what you got, Jeff? I don't know, Jeff. 4/5. Sure.
Someone put that on a t-shirt.
What's that?
What you got, Jeff?
I don't know, Jeff. Show me what you got, Jeff. Gotta rewatch that again. So final space is warning 9. So what do you do? What's the process say?
You guys subtract.
Subtract. So that doesn't change. That never changes. We just wish it was whole numbers, because those are easy to add and subtract. Shit. But we don't suddenly change how we subtract fractions to make it easier for us. It's too bad for us. We have to do this. So now I need LCD and so forth. Okay. So if you've been enjoying a bit less fractions for a while, it's too bad. They never go away. Why? Because they're real and the world works with them, and that's too bad. That sounds so simplified. So of course this is not a bad LCD, right? You need 5 there, you need 3 there. So you get 35 minus 12 over 15. Get out of there. What did it say? 35 minus 12 is? Anybody tell me, let me see if I can push you guys a little bit. How many W's is that almost? Or let me say it this way. Well, anyway. This would have to be 30 over 15 to be W squared, right? So it's a little under W squared. 1 W would be 15 over 15. Okay, I'm pushing you. So notice, now watch this. Here's something we can investigate now. Some of you guys might just know what this is. There's no grammar test, but no, grammar and math is order operation. What was we going to do? Shite. I forgot. It's too bad for us. What if I had this here? Oh yeah, I remember what I was going to do. I'll do it next. Yeah, multiply. And of course, when you multiply or divide fractions, you do not need LCD. That's the reverse of what you're supposed to be trying to reduce things. LCD is the opposite of reducing. It's building up. Yeah. Oh, shit. So what cancels here? What reduces?
60.
Yeah. So I get W to the what? I like it. I like it. In a crypt, really.
Yeah.
Nice. We're safe, surrounded by death. All right, so here's what I was about to show. Somebody might know this already. What's the square root of 12.7 times the square root of 12.7? All right, so let's do it. How can I rewrite the square root of 12.7? Is 12.7 to the what?
Two.
Careful, definitely not to the second. Square root's the opposite of that, so it's to the half. Not negative, it's not a fraction. Inverse, yeah. Times another one of these, and another one. What do you do with the powers when the bases are the same? All the time. What do you do with the powers when the bases are the same? Multiply. Add them. What's 1/2 plus 1/2? 1. So I get one whole one. Why does that make so much sense? This is half of 12.7 times half of 12.7. It makes a whole freaking 12.7. But it's so much easier to see in this form. Okay. So one thing to realize is, just because I throw in fractional powers, now we know partially what fractional powers means. All the old properties of exponents still work. You still add, you still subtract, all that kind of stuff in the right time. You just have fractions that are going to be mixed in. Yeah, like that. Doesn't change what I do, it changes how I do it. LCD and all that kind of business. So what I want to talk about now is, what the hell does it mean when I have like a 3 over a 4? What's the number on the bottom mean? What's x to the 1/4 mean? What do you think? What cuts something in fourths? What kind of thing? 4th root. I love it. Just like x to the 1/2 is the square root, x to the 1/3 is the cube root, x to the 1/4 is the 4th root. So watch this. This kicks so much ass. What's at the bottom of most plants? Roots. So the root is on the bottom. 4th root. The power is on the top. I wouldn't even have to write the 1, right? But I just did. Roots are on the bottom. I say most plants because like one time I had this person, I'm actually taking biology and I know that there's tubers and I'm shut up. Most plants, and I'm sorry, I know I'm a geek. What am I making fun of some other? But you know, I'm like, all right, it's just a way to remember. But now watch this. Watch this. Isn't this the same thing? Aren't these the same thing? You guys see that?
Yeah.
Yes. Right? So this would be the 4th root of x cubed. Are you with me? Right? Because what's x to the 1/4? 4th root? Oh, you guys, right now, you desperately have to totally, like, what's the 5th root of x? X to the 1/5. What's the 11th root of x? X to the 1/11. Bam, bam, bam. Right? Now watch this, though. I'm using you. You're about dead. I could have gone, is everybody cool with that? It's a 4th root because that was on the bottom. That's how many parts I want to cut it into. To the 3rd power because that was on top. That's the 3rd power. Now go with me for a second. I could have written this like this instead. Of course I can, because it doesn't matter what order you multiply 3 and 1/4. It becomes 3/4, right? Some of you guys are like, yeah, you can do that. But watch what this kind of does. A little bit different. What's on the inside now? X cubed. What's it inside of? 4th root. So it doesn't matter if the power's on the outside or if the power's on the inside. You can write it either way, whichever one is more useful. Why the shit would one of these be more useful? Let me show you. So what, you got a little shortcut now. How to interpret fractional powers. Bottom is the root, because that's where the root to be. And the top is the power, because powerful went to the top. Right? So how would I rewrite this problem? Pretty much gave this away, but oh well. I could rewrite it one of two ways. What's the root going to be? 4th root. I can either write it as the 4th root of 16 cubed, and then I have to cube 16. Do you want to do that? I don't want to do it. Or I could write it as the 4th root of 16 all to the 3rd power. As long as 3 is a power, it doesn't matter if it's inside or outside. Why? I proved it up there. Leave me alone. What is the 4th root of 16? What does it take 4 of to multiply to be 16? No. 2. I like it. Sorry, if you said 2, I wasn't talking. So somebody mouthed 4 is number. So 4 3 to 16 is 2, because 2 times 2 times 2 times 2 is 16. And then 2 cubed is 8. I love it. All right, I know let me push this a little bit, because this is so cool if you see this. And understand. You can see what you're writing. This is so awesome. 3/4 of something is like, what's like 3/4 of 12? Well, 4 to the 12, 3, and then 3 of those 3s makes 9. So 3/4 of 12 makes it a little bit smaller. You know, stay with me, stay with me. This kicks so much ass. Break 16 up into 4 parts. 2 times 2 times 2 times 2, right? How many of them do I want to take? 3 of them. 2 times 2 times 2 is? All right. That's 3/4 of 16 multiplicatively. Break 16 up into 4 parts. Take 3 of those parts. I love that idea. Does that mean you have to do it that way? No, it's not the most effective way to really do it. But it's so cool to see that's the idea.
If we were to do it like that, would you want us to show the work like that? Or
Yes, show me. This is beautiful.
Like
Write that,
All right.
circle those, put an 8, kick ass. I love it. Like it. All right, let's do a couple more of these. And then I got a little handout, of course. Oh. Let's do 8 to the, let's make it 5/3. I like it. Try to rewrite that in radical form. Or do it the other way. We'll see. You gotta be careful. You do have to know how to rewrite this in radical form. That would be a problem by itself. Let me catch up to you guys. What's the root on this? Yeah, 3. Cube root. Cube root of 8. And then you have a 5th power. And again, you can put it on the inside or the outside. Anytime it's a number, I pretty much put it on the outside because there's less shit to worry about with the root. If I put it inside, I got 5/8 to worry. Oh, screw that. Let me just do cube root of 8 and then raise that to the 5th power because I know what the cube root of 8 is. What is the cube root of 8? 2. And what's 2 to the 5th power?
2 times 2 times 2 times 2 times 2.
Oh gosh. You start to memorize these, maybe. 32, yeah. If you did it the other way, 8 is 2 times 2 times 2. I want 5 of these. 2 times 2 times 2 times 2 times 2 is 32. I mean, you can see how the math does that, right? Cuts it in thirds and then takes 5 of them. Maybe. All right. Here you guys, let's see. How would I rewrite this shit? This is where people get really creative. Oh, hell yeah. What do you have to do first, though? What's probably a really good idea to do first? How do I get rid of that negative? What does it want me to do? What's a negative power mean? What's a negative power mean?
That the answer's gonna be negative?
Something got to do with fraction, that's right. What's x to the negative 1? 1 over x. What's a negative power mean? Flip. Do you remember this?
Yes.
Negative power means flip. That's why we had a problem like this. What did I suggest you do first? Flip the negative powers, because that's what the hell it means. Right? So those 2 b's would come down, it'd have 5. Those 4 c's would come up, it'd have 10. Remember those kind of problems? So negative powers mean flip. Let me do that first. The mistake I see is people flip the 2/3. What the shit? Something being raised to a negative power will flip. Is 2/3 being raised to any power? No, it's just being raised to the understood 1. It's not being raised to a negative power. Why would the 2/3 flip? What's being raised to a negative power is 27. It flips. Now, how do I rewrite the bottom? What's the radical going to be? What's the root? Third root. I like it. Of 27 to the second. You guys see how to break this? If I have a negative power, take care of that first. Get that out of the way. Flip that bad boy. Wherever the shit it ends up, attack it there. All right? You rewrite the fractional power because you know the shortcut. Bottom is root, top is power. What's the cube root of 27? 3 squared. I like it. Coolness. All right, so maybe that's the place I can finally shut up for a bit. Yeah. I like it. Oh shit. So this is kind of a review of 10.1, 10.2. The other side's 10.3. Maybe don't look at this interesting looking, colorful side. Just do this boring 10.1, 10.2 side. Start with that. I'm not using the green book here for a little while because their formatting got way freaky and I don't like looking at it. If you look at the radicals in this green book, they make you think like my site's going even worse than it already is. So a sign that says 10.1, 10.2. It does say group work, but